Alright. This is question number 410. And it states, a dock worker applies a constant horizontal force of 80 newtons to a block of ice on a smooth horizontal floor. The frictional force is negligible. The block starts from rest and moves 11 meters in 5 seconds. A, what is the mass of the block of ice? B, if the worker stops pushing at the end of 5 seconds, how far does the block move in the next 5 seconds? So, we're given that the worker applies a horizontal force of 80 newtons. The block starts from rest and moves 11 meters in 5 seconds. So with that, we're going to use kinematics equation, and we're going to use this one, which is delta x equals initial velocity times t plus 1/2 acceleration t squared. So we're going to use that, and it says that the block starts from rest, so we know that the initial velocity is 0. So don't care about that. And what we're going to solve for is A, because for part A, we want the mass of the block of ice. And it's given us a force, and what we know is that force equals mass times acceleration. So we're given the force, we can find the acceleration in order to get the mass. So you can see that. So what we're going to do is we're going to rewrite this equation so that we solve for A, which would be A equals 2d over t squared. So what you do is you just plug in d, which it gives us that, which is 11, right? Yes, 11 meters. So we'll just two times 11 over, it was 5, right? 5 seconds, 5 squared. So once you compute that, you'll get 0.88 meters a second squared. That's our acceleration. So once we get that, we're just going to use this to find the mass, which is F of A equals m. And if you do that, 80 divided by 0.88, you will get 90.9. So that's the answer for part A. Part B, if the worker stops pushing at the end of 5 seconds, how far does the block move in the next 5 seconds? In order to do that, we're just going to do 0.88 times 5 and then we'll just times 5 again, which will be 22 meters. That's it. That's part B. And that is it.